What's up, everybody? I am doing the first K-Series Pinned Deck Conversion, and this is our core, and it's in pretty rough shape is why I'm going to use it, but it's still a good block. It had some flood damage, rainwater damage, and I believe it's only been hot tanked. I just took the plugs out and the oil squirters. They're all right there. And I haven't even taken the main bearings out. But I'm going to put this in the vapor hone and make it look brand new. I just finished scraping all the edges. Oh, not the parting edge here. I got to scrape the case half parting edges right in there. So anyways, stand by. I'll get this done. And I'm going to take, sorry about that if that tripped everybody up. I'm going to take before and afters. These are my before. I'm in the basement with my vapor hone, so I don't have a lot of space. Otherwise I'd get you better pictures. I did what I could. Sorry for having bad camera movements here. So anyways, there it is before, and I'll get it vapor blasted and take some pictures of it clean and a quick video, and then we'll get it out on the hone. We're gonna clean these cylinders. See that, how nasty those are? I'm gonna clean the pitted cylinders with the hone before I even put it on the mill. Just because I want to make it look nice when I do the machining for this video. And I kind of want to show how nasty this thing was before. But by the time it's on the hone where I do all the work, I always do the cylinders last on this job because we're going to be modifying the deck. But I don't like leaving them that nasty. So tonight I'm going to clean this thing and kind of clean the cylinders, you know, with a few strokes of the machine, and then I'll put it on the deck of the I'll put it on the mill, put it on the bed of the mill. So we'll start throwing pins in it. I got to study the head gasket pattern. I don't have a piston set for this yet, so I'd like to, but I don't know if it would get boosted or not. Probably is what I would anticipate. And then I don't know, even this is like even a K20 or a K24. I don't know yet. I'm just gonna clean it and find out. So, all right, I'll talk to you then. Bye-bye. Okay, today is a fun day. We have a K-Series on the milling machine to do a pin deck conversion. I just cleaned it. The cylinders are disgusting, but I at least put them through the hone to shine them up a bit for the video. You know, sorry for a shaky camera. My other camera that I have is missing in action, and I believe it's in my dad's car. So let's take a quick look here. Okay, well, I'm ready to start putting pins in this block here. And I didn't know if I wanted to let everybody know on this video that's watching here that this has never been done before. And oh boy, will people discuss, the technicals of this. Now it's pretty simple, the swap. Coolant goes up here through the head, okay? And where I'm gonna put these, it's not gonna really interfere with coolant, okay? It will all make it into the cylinder head. And when you put the head gasket on this, okay, it seals all this up. Ooh, careful. Anyways, seals all this up. And there's just a few spots that let coolant into the cylinder head, okay? So we put the pins, obviously, where the coolant, it will not stop any flow of the coolant getting into the head, okay? 2, there is not a lot of pressure because I'm going to bore a hole with this little guy right here. Okay, I'm going to bore a hole, and I'm going to be able to slide that pin in with my finger. Okay, I'm not going to make it where I got to bash it in with a hammer, prying this away from itself, puckering. It doesn't work that way, guys, okay? We're boring it in, okay? And I almost like dabbing epoxy on it. But it doesn't matter. I just don't want it to be loose enough where vibration could happen, obviously. But we don't want it too tight. We just don't want it too tight, okay? And everything's safe. So if it's too loose, not a big deal. Epoxy the pin and I slide it in. Let it cure. I gotta let it cure for a while so I can cut all the pins when I'm done. Okay, the pins will all protrude out of here when I am done. By a very little, it's 100 thousandths, so 1/10 of an inch. Kind of a weird spec there, but that's how much it will. I go 400 thousandths deep, and I have a 1/2 inch diameter pin. I think that's what it is. And then we go, basically it's a 1/2 inch diameter, and let me go get it. It's right here. You guys are going to be like, holy cow. I have this many of them. And I have this many of the other size. But it is it's a 1/2 inch by a 1/2 inch. Okay. And there's a little bit of a, chamfer to it. Okay. So that's a pin. I have a bazillion. Actually, that is 500. So I don't know if I got grease on the camera. Anyways, so time to rattle the Honda world. Okay. Oh, they're going to be Honda people. Oh, the technicals. So let's do it, and let's piss everybody off and do some innovation and get all the people who don't like innovation talking and crackling and this can't be done and it can be done and blah, 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 blah. So I'm going to go do it. I like pissing everybody off. So closed deck converted guys that can't quite afford it, this is for you. All right? You guys that are like, oh my gosh, they asked $3,000 to do my block. Dirt and sleeves, which are all awesome mods. Do not get me wrong. But this block, this mod, I should say, this is not expensive. I mean, if you charge, $10 a pin, you're going to be $240. Okay. Now, if you were to boost something like this, your average machine shop with a mill and some tooling should be able to figure this out. So anyways, we might sell these matched to those pins in a kit. So anyone with a mill can do this. Okay. Right now, it's about the only thing I do that's unique here. So I can't do everybody's block in the world. If we come out with a mod, it's okay. They're going to copy it. Okay, I've done this before. They've copied other things. So it gets copied. You might as well supply everybody with pins. And you might as well supply everybody with end mills. So I probably will have that figured out by the time anybody even sees this video, because I got to pin deck convert this thing and deck it. Make it look good. And then I probably need to order special pistons, and I'm going to finish bore it and hone it 20 over. Right now it's at standard. And the cylinder walls have seen better days. There was water droplets from a leaky roof on this. Plus it sat in a basement for like 6 years collecting dust and grime. So the vapor hone made it look good. Anywho, it looks almost brand new. I can't quite keep it shiny. I'm having issues with my pH. And this was way shinier when I vapor blasted it. Okay. So anyways, let's get this conversion done. And see how it turns out. I'm going 1/2 inch. Let me get a little more technical here for you. Okay, on one more technical on the 1, 2, and 3 here. What was I gonna say? Oh yeah, the ring for the head gasket here. Let me set the camera right here so we can look. Right there. See how there's a steel liner? Obviously, you can see the darker gray. I can't bore halfway into this light silver stuff because that's where the head gasket sits, and you don't want the parting edge of these pins to be in the head gasket area. So you want to keep it more on this end than that end. when you put it in here. Okay, so let's start cutting. You have to freehand this basically by looking from this stud to that stud. And you're gonna XY this bad boy, or your jig bore, okay? Or your CNC if you're doing it that way. And you're gonna be cross-sectioning the head studs as close as you can. But when you get in here, you'll notice you're gonna have to work a little custom because they're all a little different. Okay. That one doesn't have as much. See, this one's a little different. I'm thinking about putting one here. I'm not sure yet. There is a water jacket that gets close. I think it's like right here. I don't have one on me. I went off of pictures and I was like, are they in the crosshatch, the cross stud pattern? And the answer was no. So it's like, okay, but I'm going to probably get on Google again and look at that. See if I can't pop one in right here on both ends. I wouldn't call it necessary, but this is a prototype. Want it to look cool. It's probably going to sit in my showroom forever. I'm not sure. So anyways, time to get to work. I'll get off my milk crate. Time to do the first Pinned Deck Converted on a K-Series. So if you want one of these, hit us up. Check us out. Happy to figure it out for you. Someone else local to you might do it, and they might buy our kit. And happy to figure that out for you too. So let's get busy. Okay, well, I just bored the first hole, and I just tapped this thing in. I use this flat hammer end, and I barely have to tap it. Okay. If it was, I've experimented with these enough now. One, I like this bigger size. The small ones are harder to work with, especially when you can barely, you need a lot of a half moon shape to help align the pin down, okay? This hammer tapping is technically used right when you get it in. You'll want to have, you know, you'll be able to, it might cock on you, if that makes sense. Anyways, this one had no problem. I'm just trying to say on those small pins. Okay, so I have the first pin installed here. That's what it looks like right after I put it 400 thousandths deep. Okay. Now what I did on that edge is I take light sandpaper and because it's kind of got a edge here, and make sure that edge is gone. And that way it just walks in there better. Okay. And that's what this one did. It needs a little bit of tapping. You can't just push with a finger. Okay. I'll show you, but I'm here by myself and I don't have a cover on my new phone and I don't want to drop it. So I'll try to still take a video of me tapping one in so you can see how lightly I'm going, but it's not gentle. I mean, it's not like, I'm sorry, it's not forceful. Dunk, 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 dunk. It's gentle. Tip. And it just, you know, and I want to show you that so you can see kind of how tight these are, because that's really what you guys are probably wondering. And anyways, and kind of just what it looks like here. So I'm trying to show you. So let me keep moving. But that was the first one, and I have 24 to do, I believe. Okay, I'm back with a couple of pins in, and I'm going to show you this one I just lined up and how little I'm going to tap. I'll make sure I'm square here. Oh, I cocked it funny. Now watch, if you cock it funny, just a light tap will get it right back in there. Hear that change? Oh, you didn't see it. My camera is down trying to swing. Anyways, you can hear it change. Ding, ding, ding. So you got to give it some. Now what you want to make sure is when you're looking at, let's see if I can't zoom in and out here. You want this. Sorry about that. I hit my camera funny. You want there to be no big split, like a wedge split between this parting edge right there. I've zoomed in so much, I don't know if but right here, this edge, shoop around, that's what it will look like there's going to be an itty bitty bit of a black line, but man, you can't fit a feeler gauge or nothing in there. Okay. Now let's zoom out here and explain some more technicals. As you do this swap, you can't bore a bunch of holes and then start tapping them in. You will put pressure on this lightly, meaning there's going to be minor flex. The goal here is to put these in and have this thing technically still be as relaxed as possible. Okay. So one bore, one pin. And I should be technically, I think, starting in the middle, like a head gasket, okay, and working my way out. I should probably not start there. So I'm still new at this. This is the first time I'm doing this type of block. Normally I'm doing a Subaru, okay? So those ones a little different, and I kind of, I've only done maybe half a dozen of those. So I think that's what will be the procedure from now on, if I haven't been doing that, is start here, and that way when you put them in, you go back and forth, you know what I mean? And then that way the thing is getting more stable as it goes, and then when you're done, you're completely stable. And then we do our surfacing, and we do our squaring up on some shit, and then we do our cylinders with the torque plate, which I don't have right now for this. So if you have a torque plate for a K-Series, hit us up. And I can do a stage 2 piston rod combo of some type for this and get the piston and do the cylinders to that. And then we have a Pinned Deck converted block out there in testing. So what I got to do is basically build it up front. I don't even know who would be willing to test it yet. I'm sure someone is. So anyways, but I'm going to bring this to the new store, put it in the front showroom, show everybody, see if anybody wants to try it. And then the cylinders will be empty, or not empty, but they'll be ready to hone to whatever piston we decide we want to run on it at that time. And then at that time, we'll get the torque plate. So in the meantime, all I'm going to do is deck it once I'm done with this thing. So anywho, let's get her going. I'll keep you updated. Okay, I just checked the head gaskets on Google, and coolant goes in like a small pinhole on the outsides of here. So nothing is here. Head gasket is here. So I'm gonna put more pins in. I think this will have 26 when I'm done. So anyway, wish me luck. Okay, we're back in the shop the following morning. I'm going to show you what is new. I started trimming. Okay, starting trimming the pins. Everything was good until I hit that one, I believe. And it started to spin in a circle as the cutter hit it. So I turned it off immediately, and I grabbed it, and I could spin it, okay, like this in there. Because I was able, this one was probably the loosest one, and I was able to go like that and push it in. So I took pliers, grabbed it, pulled it out, mixed up some aluminum JB Weld, ultra hard, fast drying, whatever, and put some on this. And any one that if I wiggled it really hard or twisted it, I could feel. And I found a few, maybe 3. So along the board edge of this on both sides, I have dabbed just a drop of JB Weld and kind of uppy downied it. And then I tapped I think a new pin or even the existing pin right back in it. So anywho, I think only 3 came out and back in and had to do that. Okay. Some, I just put the remaining JB Weld on that thing we discussed earlier, right here, the parting edge. And I was like, I'm going to fill that one little parting edge so when I surface it, there's at least something in there. I don't know, though. We'll see how it looks. It'll probably all scrape out, so. Anywho, I'm going to get back to cutting, and we're going to scrape off all the aluminum pins. I had to do a tool change on my fly cutter here, balanced fly cutter. Okay, it's doing a good job, but the tool holder I have on it is wrong. It's for a square insert. It was all that was available. Now, since you can see what I put on here, more of that crap. Should be sponsored by it, right? JB Weld. Well, I had a PCD insert, which is for aluminum, but this is steel here, cast iron sleeve. You cannot use PCD. So I had to undo my JB Weld PCD, and it cracked the supporting area I put in to make it a round insert holder. So what I'm gonna run right now is just a El Cheapo carbide, okay? And carbide can handle cutting that steel and aluminum, but this is one of the hardest decks to deck. One of the hardest decks to surface. Intermittent steel and aluminum is just tough. So getting this thing to be real pretty will be tough. Plus it's almost as wide as the cutter itself. So I've got to bring this thing out and over and almost manually do it. It's going to be smeary here and here, and I hope it's we'll see how it goes. I won't know until all the pins are cut, and then I'm going to square this up with the head here. I'm going to make sure that we're even on this side as this side, and also even this end to this end with a dial indicator. So that way we know we are square with the existing deck. And that's what I'm going to do here. I'm not going to do it on the crankshaft center line. It is sitting on the crankshaft center lines per se, but nah, crankshaft center line is a pipe in this thing that's the exact bore, or on a collar on the bore, but it's on the center line on this block locked down, and that is now true all the way down. And then I ignore almost my end to end and say, yep, here's the crankshaft center line. Let's deck it, whatever it is, not being any shims here to here. And then on the tilty, they zero that out on the dial indicator, which I use this one, and I measure here, okay? So, CNC machine uses the probe and then adjust it accordingly. I don't even know if they're technically on the crankshaft center line. Look it up. Look at their fixtures. You'll be kind of interested if that's what you're interested in. Anyways, went off topic there for a minute. Did a little shop talk about how I have this thing rigged up. But for today, we're assuming this block didn't have that much damage. It's just a parted out block. And we'll find out when we put the dial indicator on it. You know, it doesn't lie. But we're going to fixture it to this. And usually it's only about 1 to 3 thousandths out ever, any which way. All right, I'm going to start trimming these. And before I start surfacing, I'll stop and show you guys what it looks like when all these pins are damn near flush. But I haven't decked it yet. So, okay, all right, I'll stop talking. All right, bye. This is the cutting head spinning. Okay. Minor vibration here, but nothing here. Kind of trippy. My drawbar is what makes noise. And I'm at 1,000 RPM. Doing about a 10 thou. I don't even know if it's 10. It could be, I went by it and I wasn't even touching these and I've moved it 10. So we have to trim these. Okay. And I don't really want to go fast and hammer on your inserts. Okay. On pass number 1. From now on, I'll just know what the load will be. On these, they're variant in height on the first pass. So, kind of feeding it slow. I'll show you what I mean. Sorry if my hand is shaking. Okay, so I have this thing feeding automatically, doing a 10 thou depth of cut. You can see we're spitting some chips. We're gonna have to run the surfacer at around 10, maybe 20 thou if I can handle it. This machine, I keep on the light duty side, obviously. And it's fairly aggressive with that hammering. So I just don't want to break an insert or shoot an insert off or something like that. So I'll just do a couple passes. And here's this one. Okay, I'm going to show you first the pins. Okay, they are rough cut. Obviously, they're not supposed to look pretty. And they are about 1 thou, I would say, protruding above. I can barely feel it. I can feel it more right here than maybe here. I'll show you some JB weld that's been machined. Now that is just a splot on top of the surface. That's not like all filled with JB weld, of course. You shall see in a moment what it'll look like. It'll basically look like this one, or like this one in just a moment. But I've got to zero out this thing, and I got to see where we are here. So first step is crankshaft center line area. We're going to zero that. And I'm going to move this in about the middle of the bore. And I'm going to sweep it over here. Okay, see that? We are 7 thousandths higher, technically. But I don't know what that is. That's still 0. That's nice. Hopefully we're 0 here. That'd be amazing. Oh boy. That means we're dead nut square on our setup, at least there. Now we're gonna do this. I'm gonna crank the handle. Where are we at here? Still at 0, basically. Now this is reading in half tenths. Half thous. So that 5 is 5 thousandths. So that little nick there is half of a thou. Alright. And we're gonna hope that we are not needing to unfasten that. But it looks like we're gonna have to. It looks like we're 5 thou high over here so far. Look at that. 6, 7 thou high. Okay. Now, when I move my table, I get a little bit, but not a lot. So what we know is we are 7.5 there. Should be 7.5. 8, 9. That was 9. 9.5. 10. So Okay. So that means we are high on this side 9 flipping thousandths. So that means I'm going to shim it and assume that's in this. I don't think the crankshaft center line and the deck are off that. I think the oil pan plane and that are off. But let's walk it back and see if we're at 0. But what we do know is that we need to go down at the other end with 2, basically 8 thou shims. Try it again. Because basically as we go down this thing, you can see we're getting back to 0. I mean, this thing's tilted ever so slightly. Sorry for the hum of the phase converter in the background. I can't do much about it. I can turn it off, I guess, but yeah, we're back at 0. Basically, we set it right about there. So when I did end to end, what are we off? 1 thou on a whole table move. Let's see here where we are over here. So we're gonna put even. What I'm gonna do here, everybody, feeler gauge evenly on both sides. Sorry. Feeler gauge on both sides, and it will pitch this up ever so slightly, just a few thousandths, and we'll measure again. Okay. All right, I just went end to end, and I did 7 thousandths. I'm actually low over here now. So something that must have been, I'm at dead nuts actually here. From back at the other end, 1 thou, which is very, very close. 2 thou low there. Dead nuts to 0 high. So if anything, this could go up barely 2 thou. And when I bring this all the way back, it's like it gets low in the middle. Okay. -2. Well, I'm not even hitting there. What's going on here? Okay, take 2. I just adjusted the dial there. So when we're off, watch the tip there. When that goes off, we are 7 or 9, what is that? 9.5 thou off the tip. See if it'll walk on though. It will. Okay, so now we're at 0. And the groove on the deck at 0. All the way out here, we drop, what is that? 1.5. I thought, hold on, 1.5. And here is basically dead nuts 0. Ouch. Okay, so we're gonna go in the middle. And remember, I have 7 thou shims over here, and I think I'm gonna be 2 thou high when I do this, and that means before something's wrong. So here I am, look at that, 2.5 thou high there compared to here. Okay, when I get in the middle of the block, we'll do a sweep here, okay? Very dead nut center. Look at that, 2.5 thou high compared to here. Wait, maybe 3. Maybe 2. What is that? 1.5? I'm sorry. That needle, when it's right on the line, it's hard for me to see, and my safety glasses are dirty. Sorry, everybody. So, and this is all low. We are all low. And when we get all the way to here, we're at 0. We're at 0. We're at 0. Well, 1/2 thou or 0. Oh, that's 2/10. negative, half, and dead 0. Look at that. So I mean, we're square end to end on the deck now with that 7/10 shim. So we might want to line hone this thing and send it out and get it actually squared up on the deck. But for today, I'm skimming this just 2/1000ths if I can. But it seems like we do have some up and downs. Maybe this thing blew a head gasket. That would make sense why this is going on. But if I can keep it to where I've only skimmed 3 thou out of this, we haven't ruined anything or cut it 10 or tapered the block where it can't ever get fixed. We're just doing the mod, getting it decked. The cylinders are horrendous anyways. There was corrosion everywhere on the mains, so it might need to have like a line hone done to it. So they'll true it up then, but it's still fairly true. I mean, I just end-to-end sweeped it and got, what is this, 2 thou dip in the middle. So we'll see what we do. I don't think I have to do any more adjustments on it. So, and I had the Z-table at 2/3 tightness. So that's where I'm going to run it. I probably could do something like this. Watch this, guys. We'll adjust the Z tightness for the run to make sure we have a barely, oh, I got a splinter in my feet. We have some adjustment here. When I tighten that, like I got what, a 1/2 thou high now. If I go a little low, 1/2 thou low. So let's go 80%. And we're at dead nut 0, basically, a little on the left of the 0. Oh, and we're 1 thou low. So if we go back here and we do this again, 1/2 thou low, let's leave it completely loose because we're trying to get it square. 1/2 thou. See that? So when I tighten this, back to 1 thou, back to 0. Now, if it's tipped this way or that way, ever so slightly, and you put the head on with the 2 cams, this way or that way, ever so slightly, it's not going to walk your timing belt as if it was this way or that way. And this, I believe, uses a chain anyways. We still don't want any of that weird this way. That's the worst. This way isn't as big a deal as much. Okay, you have your intake and exhaust. Stuff does bolt here and all, but you want that stuff riding nice and concentric on the snout of the front of the engine. So anyway, I'm going to call this good and take a skim pass and show you what it looked like when I try to skim 1 thou out of this thing. Okay, I'll take pictures too. All right, thanks for watching. Hold on. Okay, I've got skim pass number 1 happening. And you can see we have that interrupted cut, and you can see we are hitting everywhere evenly on this block. I've got the cutter scooting pretty good. I think I'm going to slow it down here just a little bit. First cut, I'm using carbide. I'm not even using CBN. You see, it's not even cutting right there. We are just skimming the top at about like 1 thou, and this deck surface is not flat. Okay, we measured it. I think it's got a 2 thou dip. So right now we might not be hitting everywhere, except for like the outsides, maybe some higher leveler spots. This is kind of like the actual leveling pass to see where the high and low spots are. At like where we measured the cutter cut at 1 thou depth of cut from the 0 mark when the cutter bit touches the highest spot of the deck. So you measure where that 0 is, the highest spot, and then you go touch off the tool tip. See that 10 times fast. Touch off the tool tip and 0 that out, and then we're doing a 1/1000 depth of cut here. Probably speed it up just because. Oop, that's slowing it down. Wait a minute. Oh, there you go. 1 millisecond faster per turn. Just we're not touching pretty much anything right here. So we will be. I bet we'll be touching that. Yep, there we go. We should be touching that and that around the same time. And the reason why the rest of the deck isn't getting hit, like I said, is this block has a little bit of a dip in the middle. Well, I'm kind of doing this a little backwards. I decided to just send the cutter bit back, okay? And when I backfeed it, it bites about 1/1000 deeper. So here's second pass. I'm just doing it backwards. Kind of interesting. You can see it right there cutting. It's done a really good job. Okay. It's just smearing a little bit because it's not quite cutting here, you know, in some of the areas that were still low. Here I didn't try to get it yet. I basically walked it here, it wasn't cutting, and I walked it back, and it started back feeding and hit here and smearing. So I'll hit it on, but it's only hitting 1/1000, so when I come back with one, and I got to touch this area with 2, it's not going to hurt anything. But there we go. See right here, you can see some rubbing with a tool bit. It's not that it's not cutting, it's just that's the lowest spot. But you can see it drag something. See that line right here? It's smeared and rubbed. So that's what we get with a not flat surface first cut, maybe. Okay. And then finish pass, you shouldn't have any smearing outside of like steel, or this potentially could have been a bit of JB Weld it grabbed. You know, that's got a weird material if it's smeared it across. You see some smearing there on the end. I'm not in love with that. But that's just what happens with this thing is not even 11 whole inches. I think it's about 10 and a half. I know it's 11 inches. So 11 inches from where the cutter tip hits. So I'm pretty sure. See how if you look here, the cutter tip's actually on the other side of that circle. Even though the thing sticks out pretty far, you know, the actual cutting bit is the very bottom of the circle. Alright, so it's doing it. It's doing a great job, in theory, you know. This is not a finished pass. I do not have any wrinkles. This is very smooth, actually. Right in here. I'm like, really about that. So, okay, so I'll set this up to show you what it looks like here in a second when this is done cutting without the noise. And we'll get a good look. That's what it looks like so far. Sweet. Okay, give me a moment. I'm going to reset this cutter. Okay, I am back. I rotated the tool cutter and it looked like there was some stuff on the bottom of the cutter. So now it was, I think the insert must have moved. It must have, I think, but I'm not sure. So it's cutting good now. I dialed it right back in with a new edge, which is like what I was going to say. So that new edge is definitely doing a good job. Let's see what it does right here. It's got literally like no depth of cut to it. Okay. 1/1000 depth of cut maybe. See how it's cutting nice and clean compared to the white. the rust on that sleeve getting cut off right here. See those little pips? That one didn't get cut all the way off. Okay, so we cut there, and we cut everywhere, all the way evenly. We had smeared something through this edge. We're not catching quite there. The cutter will reach it. So we're good. That was a 1/1000 skim. Okay. Out here I kind of missed it. I started back feeding. It did the 1/1000 skim. Looks like we even hit here. Now I'm doing this dry, and I'm supposed to have WD-40 or something on it. So, all right. So I'm gonna cut. We are at 1/1000. I'm sorry, that's 2/1000 total. I'm gonna get this to about the 4, and give it the old 80%. We're good to go on this. I took pictures already. So I'm just going to use some bullshit. It's all right if a little goes on here. It kind of lubricates this, which, by the way, I just had running for damn near an hour, and I can touch it. It's not even that warm. It's barely warm. Okay, so I'm going to go back on that. I'm going to go forward. I'm going to slow it down. That's faster, that's slower. It's real slow. Okay, so now I'm giving it a slow pass at a fairly good depth of cut. I think we're at 2. It was barely touching, so I gave it an inch more. We're at the 4.5 to 5 on this thing. So I think I took a 1.5 top to bottom off. And then when I went back, I think we went back on 2, and now I'm at 5. And I'm definitely taking a 2,000 depth of cut right now. So I think I took out 3 on the original pass and back pass. So maybe 1 thou off some of it the first pass, and then 1.5 thou off the back way, or even 2. Probably 2, because I said 3, right? So 1 and then 2. Anyways, we're hitting that steel nice. We're hitting the inserts nice. Hitting all areas of the block nice. I think I need to really lubricate that. What I'm going to do here. I'm going to leave this. So that way when we start cutting there, the rubbing is not a heat, does not create any heat. I probably should try to get this thing on the crate and shift center line a little better. I'm kind of doing it offset because of this big thing here, so. Okay. So far so good. Cleaning it up all nice and making it look uniform at least. It is very smooth. Okay, and you can't tell here, but it is really reflective. See how our rub mark goes away? Not quite. I might rotate the carbide insert on our final pass, so so we have fresh carbide edge. It's probably a good idea. It would take on a lot of, this insert has seen a lot of hammering on that spot. So since it is just a carbide and not CBN or PCB, technically you'd use CBN. I don't know where my darn insert is. So, and I want this to have a good finish. So sharp carbide once, I think, is just as good as CBN, which lasts way longer, you know. But for something like this is experimental. Anywho, I'll show you the finished product here in a minute. Okay, I'm on my final pass. I'm taking about a 2 thou depth of cut. I'm going real slow on the feed. And it's interesting, when there is no steel, the aluminum cut brightens up, like right here. It's getting ready to do it. See that? No steel. Now we got a clean line. Oh, steel again. Steel on that cylinder, back to white. Okay, nothing I can do about it. It sucks. It doesn't look good. I mean, it's fine as far as measurements go, but it's like as it's cutting steel, it's just such a, hear it ringing. First, this thing's literally a big bell, is what my dad said. It's like a big bell. When it's hitting that steel, it has got different harmonics in it. And I don't know if that's what makes the cut look white. But man, every time it goes in between the cylinders, you can see it right there. Watch this. It does it there too. Watch this. Oh, it's all shiny afterwards. Okay. Yeah, it looks, you know, it's shiny there. It's covered in chips and whatnot. Hear that harmonics? Because the cylinder wall gap from the left side to right side got bigger and bigger and bigger. It's almost like we have major chattering going on. We might need to do an emergency stop. Stop. Did we chip an insert? What is going on here? Well, now I have a 1 thou dip. Well, maybe it's not a dip, it's the step. The step from one to another, but you can see where something started happening. This is not right. I wonder if my insert got loose. Like, started moving? Because we started getting some major chatter. You could hear it. Wasn't normally doing that. I got some issues to surface out here, friends. This is not good. That's not acceptable surface here. Okay. Looks like it started here. Very smooth. Chatter. There's one trick which we can chamfer this edge. That's not what's going on here. Look at that. Here's where I stopped. This is just where it was clean. This is clean until then. I'm gonna re-tighten that cutter. I don't think it is the cutter, but I'm gonna just assume it is. So give me a second. Normally I don't have an issue like this. This is freaking me out. Okay, I am back. I rotated the tool cutter and it looked like there was some stuff on the bottom of the cutter. So now it was, I think the insert must have moved. It must have, I think, but I'm not sure. So it's cutting good now. I dialed it right back in with a new edge, which is like what I was going to say. So that new edge is definitely doing a good job. Let's see what it does right here. It's got literally like no depth of cut to that bed. One down depth of cut maybe. See how it's cutting nice and clean compared to the white. The rust on that sleeve getting cut off right here. See the little pit? So that one didn't get cut all the way off. Okay, so over here, everything looks great. But as we get to where the insert had its issues, somewhere in here, this area is very chattery. So I'm gonna cut another. It's all good over here though. A little smeary. So we're going to give her another go. Get my safety glasses on. I'm going to go slow on this pass. It's technically a final pass. I'm assuming I did a high enough depth that we will yeah, we're cutting. I just wanted to make sure. It's hard to see when it's cutting the spot that's just identical to it. So now you can see it. And we're getting ready to go into the saddle here. Right now we're cutting the saddle. So I think I have it a little bit more on the crankshaft center line this cut. I might want to move that this way a little bit. And then tighten that. I'm going to tighten this a little down. That's tight. Finger tight at least. So hopefully we cut deep enough to get rid of this chatter. Otherwise I got one more 1/1000 pass to do. Real slow. I'm doing it real slow. I want the best finish now, and that is the way to achieve it, is go slow. We don't have to go crazy on the slow. We do need to have some bite, but you want to not load the machine spindle as much as you can. So, but it needs some load. So you kind of want it to have like, imagine like a 20% load the whole time. So far so good. I'll leave you rolling here. I'll leave you rolling to see where this chatter is. Chatter is right here. Sorry about that. Chatter is right there, and we are here. We're going about, I don't know, 1.5 to 2 inches a minute. Not real fast. So I'll bring you back once we get here. Hear those harmonics, huh? Okay, so obviously hitting the same spot, just fun harmonics here. So far it looks like it's cleaning up that chatter. You'll be able to tell right now as it's passing over that there'll be ugly spots. It doesn't look like it. There'll be a tiger stripe. Basically there'll be low spots in that chatter. So far so good. I'd love it to do a cleanup pass right now. It would qualify for cleanup pass if it gets rid of this spot right here. I'd say it's doing a pretty good job of. There's one streak that has nothing to do with the chatter. Anyways, looks like it went right through that. Its chatter marks are gone. It'll start to make the rest of this thing look exactly the same. We're going to get our wild harmonics back as that cutter closes into the two cylinders into this spot. Ooh, I'll keep my finger away. Away with your finger. Alrighty, well, I'll show you the finished product as soon as we're done chiseling away here to the end. I'll blow it off, and we will be done with our first conversion from the looks like of it. So, the looks of it. Anyways, a Rickyism for y'all. Okay, here's the halfway point in the cut, and I'll let you guys go with that. Don't forget to subscribe, and I'll have a link in the description on more information on this, or where you could go to our website and see the pictures that I took on this project here, because I've been taking pictures along the way. And yeah, pretty cool little mod. I hope you guys like it. It's for you guys. It's a We the People mod. You do not need a CNC to do this. It's pretty simple. It's not for beginners, but for those with a milling machine and some tooling, you know, and some know-how what you're doing and what you're not doing, something you can possibly get done at your traditional machine shop, assuming they have a mill, and you hand them the kit, which is the end mill and my pins here. So, right in the description what you would do with the K-Series with pins in it. Probably boost it. This happens to be a 2-liter. The 2-liter I think is more high rev, 11.1 to 1 compression. So I don't know if it's really needed on this K20A2 block, but the K24 would boost most definitely. This was just all I had. Anyways, I hope you guys enjoyed this project video log. I'll show you it when it's all finished here in a minute. I'm going real slow on the feed on our final pass here. So, alright, thanks for watching. Subscribe, everyone. Thank you. Bye-bye. Alright, I have an issue here. My carbide has worn out from new, right in here, nice and smooth. Sorry for a dirty finger. And you know, everything's fine until here. We start wearing out right here. And I got dippies. They're not bad. I just wish they weren't there. See, oh, you can see them perfect right there. See, those are called chatter marks. Those can cause potential head gasket leaks because there's high and low peaks in that. Okay, now when I switch the insert, you can see how they're real bad. Okay, switch the insert, and they're fine. Then I had to move the cutter head down here to cut the end. Okay, so that's why there's different hash marks there. So that's what that looks like when you're all said and done. They are in there, nice and flush. Okay, these are the ones that I put JB Weld in. See that? There's going to be a little layer of JB Weld in there now. See, you can see my little bit of it right there. But that's what it does. So that way it's filled. Okay. This is very smooth, but you can see, look at that. I'm zoomed in as much as I can. You can see the differences in materials here. Cast aluminum, extruded aluminum, and steel. Okay. And that's what we have going on. That's where the back of the cutter hit. Here, that's what the back cut. That's not really great. It's smooth as can be though there. So here's what I'm gonna do. Pops gave me something. Where'd I put it? Oh, it's over here. Okay, so let's zoom out. These are my inserts that are all experimental from my dad. He owns a big company that does this type of stuff for real machines. Now this insert right here, he gave to me because it's for this, but he was like, I'm not even gonna market this. Look at the hair on that. Sorry about that, everybody. I don't know if this is PCD or CBN. I think it's yeah. Okay, so this thing is weird and special, and we're gonna ruin it just because this is carbide. Probably I don't know how cheap an insert, 10 bucks. Oh boy, where'd I put? There it is. We're gonna sell these for this little guy here because I lose them and it's loose. See that? I don't love that. Oh, backwards. Righty, tighty, lefty, loosey. Okay, so here is our JB welded. See how there's JB weld on this thing? I believe that was hitting on the bottom at one point. It's causing my chatter. But it's, I think, just not getting, it's not staying in this old piece of crap tool holder part. See how I'd have a JB weld to hold this top area. Regardless, we're going to put this ultra sharp test insert in here. Okay. We're going to do that. Give me a sec. I got to set the camera down. Okay, we're back. Hopefully this thing doesn't shoot out. They can do that. That's why I put JB Weld in there to begin with. In the name of Jesus. In the name of Jesus. This thing shall cut. Feed her in by hand. See that? Not there yet. That cutter has like a up sharp concave dealio. Don't even touch it. Something. Okay, now I am. Look at that. All right. Let's do it. On. Where's my spray? My spray. Yeah. I think my depth of cut is at 0, which is not great because that means we're just going to rub the tool. We're cutting. Oh boy. Let's try this one out and see if it lasts. At least it's diamond. It's too sharp of an edge. It's not going to have like a 90-degree cut. Shear edge. Plus, I think I'm a little more see my cutting angle on those. I think I am What way am I? I'm fine. I'm just gonna leave it right there. The goal here is for this to stay sharp through that steel cut. And to have the best finish we can. It looks like it's gonna have a better finish. Barely. Just barely. The hope is we're deep enough to get rid of that chatter. I don't know if I have a very deep cut here, guys. Like a half of a thou. And that's kind of unfortunate because I can't start over. It's touching everywhere. We're doing fine. Oops, sorry. Alright. We're touching there. I'm probably making every one of you sick with my camera movements. So I'm gonna back out. Oops. Oh. Alright, here it is. Right off the press. We can see I have a little bit of chatter I couldn't get through here. I don't know if I could feel that or not. But, oh, there's the other area of the chatter. Ew. Other than that, this thing is very concentric. This is from the other pass. That is not from now. Those are just the lows of the chatter marks. But as you can see, the rest of it is really nice. Pinned Deck Converted K-Series. Who wants one? Give me a call. Can do a better one than this next time for sure. This is my practice. We'll get this figured out. Basically, this machine cuts 14-inch wide. Huge cutter head somewhere. Oh, it's in the other shop. So when this is done in like a month, I'm putting new wheels on it and a new motor and a special drive assembly so it's more controllable. Kind of like this one is. But yeah, look at that. Let's zoom out here. See that? That's nice. Still a little dot there. So you can't even see any JB Weld at this point in the game. It's all been cut off. Maybe like right there. But I might pick that out with a rat tail file. This was our problem one, I believe. And you can see at this point it is not a problem at all. So anyways, there it is. Like, share, and subscribe. I hope you guys appreciate my risk and reputation for doing this. If you try something new in this game, you're gonna get haters all over the place, okay? This is the automotive game, okay? There's gonna be an engineer out there that's gonna tell you this is junk, and there's gonna be an engineer out there that tells you this is great. So it is what it is. Pinned Deck Converted. For the poor boy that does not have a CNC machine like me, we could handle this. All right. Thank you, guys. I hope you enjoyed watching me dink around on a Saturday making this thing. So, all right. Bye-bye.